Hi everyone.
Muted.
Good morning or good afternoon, depending where are you in the world. Airports are starting to pay more attention to passenger journey and trying to provide more pleasant experience. Airport will likely need to look at every process and challenge every traditional operation model. To do so, airport will have to overcome some of the following challenges. Airports are lacking of holistic view of their operation because of poor information exchange capability between stakeholders. Silo operation cannot survive. Slow and reactionary decision-making is increasing operation costs, particularly in time of irregular operation like what we are facing this day with the COVID-19. A delay in decision-making could lead to domino effect on airport operation and unnecessary disruption of the passenger. Quick decision-making and stakeholder collaboration are becoming crucial factors. Airports also need to look forward to understand the threat and opportunity that new technology could benefit the airport. They need to be analyzed holistically how this new technology will provide benefit. Therefore, airports need to set up the condition to benefit from this new technology to provide necessary flexibility that airports are looking for. Looking to the future, airports must assess their overall experience and rethink their operational model to keep costs down. They must adapt for greater flexibility, creativity, and quick decision-making. The adoption of virtual twin technology will allow airports to evolve toward holistic decision-making and advance the airport to the 21st century. So what is a virtual twin? The virtual twin is a replica of the real life and provide the link between virtual and physical environment to help improve the real. It reveals insight into the airport performance by simulating, for example, a day of operation at zero risk and at zero cost. And this is what Dassault Systèmes to the Experience platform is about. It provides what we call a virtual twin experience. The virtual twin experience is the next evolution of digital airport, or some call digital twin. It goes beyond digital twin technology. Not only it provide insight into airport operation infrastructure and passenger experience, but also open up infinity possibility through what-if simulation scenario to explore different strategy in solving operation problem before it become real. Simply, it help airport assess and understand their as is, but also help airport plan their to be. The virtual twin experience enable airport to create a consistent and comprehensive experience for all stakeholders, from design, construction to marketing, sales, and operation. It provides a business platform to help airport transform to the 21st century. It is already being used by many customers in many industries and in a number of major projects like for the aerospace, for aircraft design, or also infrastructure project like Singapore airport, virtual Singapore, sorry. The airport experience is providing three major breakthrough technology. The first is system engineering. We are looking the airport as a system and system of system. You have the checking system, the baggage system, and you can really connect all the system, which provide you a holistic view on operation. So if you have a bottleneck at the checking, you can understand what is the impact on the other systems, so you can provide the best solution to ensure that overall airport will continue to perform on the maximum level. The second is really what is about the virtual twin is providing airport simulation and behavior simulation. And it can go from passenger flow simulation to any other sustainability simulation, which include electrical consumption, include noise or any HVAC system that you can imagine. We can also be able to fit the virtual twin with IoT information. So now we can run what we call real-life simulation into the virtual twin. And finally, airport is about the passenger experience, and you want to be able to measure what is the experience you want to provide and all the change that you are going to do and improve the airport, how it's going to improve or impact your passenger experience. So the ability to be able to modelize the experience and simulate this experience could provide a good understanding on how the airport should look and improve their operation. The airport experience is really organized around 5 main pillars. The first one is what we call the upstream thinking. Upstream thinking is really helping in early concept or innovation phase, where airport is looking to improve operation or bring a new innovation project. Today, by discussing with many airports, we find that ideas are remaining in the head of someone. They have difficulty to understand the impact of the idea, what is the benefit and how we can measure this benefit in one side, and the other side, how I can communicate my idea to my stakeholder to be able to secure the capital funding. The possibility of being able to modelize the idea in the virtual twin, be able to simulate, provide a benefit to airport to understand where they are going to spend the money and what the benefit they will get. Not only that, you can also be able to measure your passenger experience and be able to retrieve from you the passenger experience some innovation project that you can capture within the platform and be able to track this information to improving the annual passenger experience. And finally, how all this would be integrated to your master plan. And when we look on the master plan, we want to look at the master plan as a system. Instead, organizing your master plan as a requirement, we want to reorganize the master plan from a system perspective and understand how this could be impacted and how you can simulate this master plan to understand the impact of the innovation you want to bring. So for example, if I want to bring new technology like what's happening today with COVID-19, a lot of touchless, you want to understand how this new system that you want to bring into the airport will impact the overall airport experience. The second element is about design and engineering. And we know that airports don't do design, but rather the subcontract. But it's very important for an airport to be able to consolidate very fast all this information coming from supplier, be able to organize this information into a single source of truth to a federated 3D view of the airport design, in which now you can start performing advanced simulation in terms of design quality, in terms of simulation, structural simulation, but you can start earlier here, starting looking on operation simulation to be sure that the airport will fulfill what it's planning, what we plan in the master plan. And some airport, as we are discussing, they are also looking early in the design how they are going to simulate the passenger experience or the shopping experience in some case of the airport. Working with some airport, we find that only by creating a collaborative design environment, what we call a CDE, we can reduce design costs by 20%. This is not including how if we improve the quality, we ensure that we can improve and reduce costs over even more than 20%. When we go to construction, it's very important for airport to understand how we can, how construction can minimize passenger disruption, to understand, to be able to simulate the construction and the operation, to understand if I close a runway, I close a gate, what will be the impact to minimize disruption in the airport. Sales and marketing, now that I have my virtual twin, I can really use this virtual twin for, as mentioned, to create experiences, and experiences can be created at many different levels. There are some airports creating what they call a maintenance experience, where you can fly to the airport, click on an asset, have all the asset information retrieved. But also working with other airports, it's very important for them in terms of marketing or also signalization, be able to understand where to put these panels and signalization in the airport, depending on different configurations. So having a sanitization of the airport, if you have 1,000 passenger or 10,000 passenger, it's not have the same effect. And you want to be able to show that the panel are enough visible, depending on number of passengers, so you can find your way within the airport. And finally, which is the most important, is how now I can leverage the virtual twin for maintenance and operation. And when we see maintenance, is really how I can connect the virtual twin to my IoT, be able to really monitor in real time, retrieve the information, be able to react, not only have a situation awareness, but improve my decision making, understand the as is, and be able to react faster, take the right decision, and be able to ensure the execution of the maintenance in efficient manner. And when we get to passenger flow optimization, is really to understand what will be the optimal configuration depending on the volume of passenger to ensure point-to-point minimal time. So we can say that the airport experience is organized around three main blocks. The first one is about collaborative design environment. To ensure coordination, operation, and collaboration among internal and external stakeholders while maintaining an integrated referential for all the airport and help delivering project on time, on cost, and on schedule. The second is about maintenance operation and inspection. It provides a single source of tools for all the facility asset and maintenance operation. Further, through simulation, we can analyze the source of the problem and provide all the necessary information to accelerate its resolution. All this information are then captured and communicated in 3D to the field via work order to accelerate maintenance, repair, and reduce maintenance costs. Based on some customer study we did with some airport, we are estimating a 6-month ROI on this module. And finally, about airport operation is really how we can improve, reduce queue time, and improve point-to-point passenger experience journey. The integrated on-beam environment provide what we call an integrated single source of truth, where we can bring data from external. In most cases where we're currently working in some airport, we can really bring data, mostly will be Revit data, to create the initial markup. So if you are doing design, most of the subcontractor will be using other system CAD. And all this system can then be federated in a single source of truth and single view, in which now you can really starting to do a lot of providing an integrated environment where you can do a lot of design conformity to check rules, to check against design, to validate your quality, but also starting to do early simulation in terms of sustainability or any other advanced simulation you are looking for. And finally, be able to create some experiences to see how this design and how this renovation that you are doing could improve your passenger experience. You need also to understand that this environment not only could be applied to new design or new renovation, but we're also working in similar approach to airport that already exist. And now we do reverse engineering through the same process and now create an integrated environment for existing airport in which now they can ensure what we call design conformity, because many of the airport, as they do in the time, some renovation, they lose the conformity and they lose the certification. So it's very important for them to maintain the single source of truth to ensure that any design will not impact their conformity and certification. So let's go and see in terms of demo how everything is working. So we have the possibility to be able to monitor passenger experience through connecting to social media or any other system, be able to measure the passenger experience through our Proxim solution that we just bought. We can also analyze the text and then be able to measure based on what passenger is telling you, analyze the text to be able to better measure the passenger experience. For example, Air France is using the solution connecting to their customer experience solution to be able to better measure and react in real time on some of the comments. Here what you see is how we can also compare your passenger experience versus other airport. You can drill down to some of the comments and that are bringing interest. And in our case, we are having interest here, but why not to integrate a self-baggage system? And then you can capture the idea in the platform and then start creating what we call an innovation project. This innovation project will be captured within the platform, and really now you can starting developing the project, be able to create through a collaborative environment, create a 3D concept on that video that can be communicated and shared with other stakeholders to really see, what this idea is going to bring and be able to secure the funding much faster. And what is very important now is all this change as they are going, you want to understand the impact on your master plan. And here, this is really how we are looking at the master plan from a system perspective. So you have really the functional description and the logical description of all your airport system. And of course, you can have drill down until every system. And by introducing a new system, you want to understand how the system will impact. So you can run different type of scenarios on the system element and validate also the system against its requirement that was defined to be sure that the system will meet the requirement. Later on, when the 3D will be available, then what you want to do is how you going to simulate the master plan against the physical element and the 3D to ensure that the 3D will fulfill exactly what the master plan is looking for. Now that my project was approved, I can really bring starting my project management, integrated project management. And of course, we can integrate with third-party system. You can bring template and be able really to assign to subcontractor and have contractor measure, control the project and be sure that the contractor are providing the deliverable in a full control manner. You can also create a space for the supplier in which they are going to deliver their drawing or their design. In our case, you can see Revit data. We can view and the Revit data within the platform directly. And when you are comfortable, and we can manage this data within the platform, but also what is important is as you are satisfied, what you want to do is convert this data into the platform. So now you see we have in Revit, we have developed an integration to Revit, and directly now you are going to convert the Revit data within the platform. Now the data are natively in the platform. Now you can leverage the full power of the platform now based on this Revit data, and of course enhance the intelligence of the data. So now you can perform advanced simulations. So the first thing that would be interesting for me in my case is to understand the usability of this new machine, how it's going to be operate in some scenario case, in what if scenario. And then what we find here that of course the space between this machine are not sufficient. So what I want to do now is using the power of the platform, I want to be able to automatically recalculate based on these new constraints, what will be the optimal design, and then resimulate. This will be then captured will be captured under what we call an issue management, and then capture within the 3D information and send that back to the subcontractor so they can update their drawing and Revit data and bring it back to the platform. Now then, as they bring back to the platform, what I can do is all the time be able to ensure the versioning and be able to compare the design to be sure that I'm converging much faster to my design. By only doing that, you can really accelerate your design, have a better control to deliver on time and on cost, but ensuring as well a high level of quality. Now that my design is done, what I want to do is going to advance capability, as I mentioned, to looking on sustainability. So I can, and what we see today, a lot of, for example, touchless capability and how the network with the airport 5G will be supported, and you can really simulate that, or you want also simulate the acoustic, how this new machine will impact the noise within the airport and what are the design changes need to be done. As well, this is what also we are providing for COVID-19 is be able to simulate your HVAC system in terms of air filtering and cooling system to be sure that what you are going to design on what you have today, or maybe what you have already today, it's sufficient based on new condition. And of course, you can, based on that, see how you need to look and improve your 2B process to ensure that now you're providing a better experience and secure environment for your passenger. And this could be extended to other simulation like energy consumption, but also to passenger flow simulation. Really, I can understand here by putting this new technology how it's going to impact my passenger flow, because you have a lot of different behavior. This could create some bottlenecks should I need in some time open more desk, and because people are not using that. So you can have a lot of what if scenario, or what are the design change need to be done in the airport to be able to ensure that we take maximum benefit of this new technology to improve in the end passenger flow in the airport. And finally, when I get to the closing of the project, you have the full dashboarding capability within the airport, within the platform. So you can really look on your project to be sure there are no issue, there are no more, everything was delivered on time. So now you can go to the project closure and for electrical signing, and of course close the project renovation if necessary. But airport is renovating constantly. As we get to maintenance operation, so really on the maintenance operation is organized around three main domains. So we have all about predictive analytic, where we can really provide advanced analytic in terms of maintenance analytic, but also do what we call condition-based maintenance, be able to solve problems based on historical information. And then you have all the monitoring, on real-time monitoring about IoT, so I can get information and have all this information encapsulate into my single, what we call operation dashboard, where you can see alert information, but you can see also a 360 view of your maintenance operation. And then what is important is then ensuring the execution of the maintenance in efficient manner. So how I can help to identify an asset very quick, search for an asset, identify the asset, and then how I can issue work order to ensure the execution with enhancing a work order with 3D information, and then be able very quick perform maintenance and close issue faster. So in terms of facility intelligence, so we have here a solution that will give you a single dashboard. You have all the information necessary about the airport asset. So you can query an asset by zone, by its asset, or if we get an alert, we can really identify from the alert and reposition where the asset is about. And then you can really retrieve all the information about the asset. So you can tag the asset based on color, so you can really understand, classify the asset in a smart manner. And then you can retrieve all the information. And this information can come from the platform or from any asset management system that the airport already have in place. And then you can really retrieve all the historical information about the assets. You really understand all the maintenance and all the documents attached to the asset, and all the issue was performed on that. So people on the field can really understand all the information, the historical information just before they start performing a maintenance activity. And this application is of course available on the web, so really compatible with any mobile solution. The next, what is very important, is now I want to starting monitoring my activity, and we have a new solution that provide a real-time monitoring capability where we can connect to any IoT platform, and we are currently working on some opportunity with many airports. And really, an alert can come, and automatically what you're going to see here is the alert is going to highlight the asset, as you can see here, the bridge, and retrieve the information coming from the IoT telling me, oh, this is the alert coming, the heat is very high. So very quick, what I can do is create an issue within the platform, capture this issue to communicate with my stakeholder. In our case, since it's a bridge, I want to communicate with maintenance, but also with operation, because now I cannot assign aircraft to these gates. Now that I have this alert coming and an issue, what I want to do is be able to look in my historical information about this information. Is I have if this issue already exists and how it was solved, so I can really capture the information. And in our case, this issue was existing, and we can see that we have what we call the walk instruction was capture how to really what are the maintenance procedure for this issue. So really, I can visualize that. What is important here is that now this information can be all captured, encapsulate into my work order. And you can see we bring the 3D information and the work instruction and really detail step by step. This going to be run in a laptop on the field for the people in the field, so we can monitor the execution of the maintenance operation and be able to be sure that it was done in efficient manner. And if, for example, nothing was done yet, then I need to create an alert. So really, as soon as everything is here, I can then bring back the IoT and pull back. So for that, what we are doing is creating. We have what we call a cockpit manager, where now you have all the work order. You can assign people, but you can have work order per color, so you can really monitor every work order that in high priority to be sure that everything is executed in manner. And if not, then you can of course create an alert to understand why it's not done. As discussed, the same alert is providing impact into my operation. So really what you want now to do is what is the impact into my state and gate, all the aircraft going to be assigned and what going to impact on the passenger. And this is really what operation excellence is about. So operation experience is really organized around 3 main modules. The first one is about operation planning. It's already doing short and long-term planning on any airport asset or resource. So really you do resource management or any asset, and this is really what Dubai is using in production today, where you can really do your planning, but also do what if simulation to define what is the optimal planning that is looking. And then you have what we call the optimizer is really when you have a disruption, what will be the holistically as you look on the airport, what will be the optimal configuration to overcome a disruption. And we'll see here in our demo very soon, since my airport, my gate is closed, I may pull up some aircraft to some stand, and then of course it's going to impact connectivity of some of the passenger because now the transfer could be longer. So maybe what you want is to look on your airport operation asset, what is open, to understand what additional resource you need to open to ensure connectivity for some passenger. And based on that, you can take advanced decision. And of course, you have a forecasting, which is now it's crucial to understand, to be able to forecast some aircraft delay or how many passenger and passenger flow, so you can really feed the planning to have the optimal planning based on some capability of forecasting. And all this is going to be connected to our operation executions, because it's very important, not as I have a planning, to be sure that this plan is executed. And what you want is to have the feedback loop to operation. And this is really what is operation intelligence about. It's really be able to monitor my planning. And then if there is a disruption in my planning, so it's not executed on time, I can monitor the feedback loop and be able to react faster. For example, if in our case, the fact that now many airplanes going to change gate, maybe catering will not be aware about the change. They will not go to the new gate. Could create some delay on time departure. I can get an alert, see, catering was not there, so I can really monitor the execution of the planning to ensure. So, as mentioned, in our case, what we are going to do using our planning, we are going to notify the planning that the gate need to be closed for a given hour. In our case, 4 hours. And what you see here is how we do it manually, but in the real case, this is going to be done automatically. So really automatically, we can reassign and recalculate. the planning, and now this is going to provide a new planning to accommodate this new issue. So what I can do now, go back to my operation planning, is really I can now visualize the new planning. So I can import the new planning, and now you can visualize this new planning and have really the connection between the plan and the physical. So you really understand which airplane to aggregate. So you really have full collaboration between the planning, and then you can really visualize all the operation that's happening. You know, in our case, many airplanes will be towed to the stand, and etc. So, and then you can also have in the single cockpit understand where my issue status is to know if I'm going back to a normal operation or not. As mentioned, in our solution, so some of the gate will go to the stand. So what I want to understand is the impact on the passenger flow. So our optimizer is connected to the AODB. So this is where we have all the flight information and connecting information. And I see that I may have some flight and passenger connection impact. So what you want is to visualize what is the path that this passenger point to point need to take, and what are the resources that here what you see, and what are the resources that are needed for him to go from gate to gate, and then you can want to find what is the optimal path you want to give him, and what you need to optimize your path to ensure connectivity on that. And of course, based on that, you can also take different decision, maybe send someone to the gate and accelerate the decision. You can also, to the platform, you can define very complex processes. And as mentioned here in our case, it's going to be like the turnaround process. And there are many different processes, long-term run process, short-term run process, but you can have defined complex processes where you can start monitoring these processes. So now I can monitor my turnaround. Each time an aircraft coming, I will instantiate this turnaround process, and I will ensure now, connected to my planning, that the resources are really executing based on what my planning is telling me. And if I don't see that activity starting, I can then alert to ensure that I can guarantee the on-time departure of my. In our case, you can also do a lot of analytic on the information on operation. Here you can see all the delays we had in a week, and I can find that someday we had a lot of delay. I can drill down to the information, to our analytic capability, and then really understand who impacted the most the delay. And we see catering, and then from catering I understand which catering company and what the airline was impacted the most, so I can now really take the right action to remedy action to that. So really the airport experience provide an end-to-end solution from initial design to maintenance operation, and now we are starting and working on how we can now integrate advanced solution in terms of shopping experience into the virtual twin, into the airport solution. So really the benefits are numerous. It provides visibility among all stakeholders by synchronizing all stakeholder information in a single source of truth and foster real-time collaboration. It helps improve efficiency to continuous improve operation and cost reduction. Provide the flexibility and the necessary flexibility are looking for, and the predictability, which enhance with unexpected situation by providing a holistic view of on improving airport operation and understanding how those adjustments will improve efficiency, effectiveness, and agility. And finally, how it can help bring growth to airport activity by providing more connected and integrated solution to help airport make faster and improve decisions. So really the takeaway I would like to bring today in my presentation is first, think beyond traditional silo approach. The increased complexity of the cyber-physical airport, as well as the operational environment enabled by the internet, by IoT, thinking beyond the traditional silo approach. You can really. The second is about think on a platform approach to improve decision making. Increased level of confidence in decision can only be achieved within integrated environment that closely tie together the digital and the physical world. And then think about transform from linear thinking to system thinking. The complexity of the airport creates significant challenge when it is not approached from a system perspective. Through a system approach, airport can ensure holistic and agile operation to deliver a highly customer-centric delight traveling experience. And finally, think virtual rather than digital, because virtual is about what is possible. Dassault System 3D Experience is proven to be the virtual twin experience solution leader in the market. And I propose now to go to Q&A session.
Unmuted.
So thank you, Isaac. So let's now start with the first question. How does the virtual twin result is more robust decision making?
So really the virtual twin provides you an environment where you can better assess the situation and so have the situation awareness, but also be able to assess through simulation about what is the problem is about, so you can take the right decision. But also you can do different what if analysis if the time give you to understand how the decision will impact overall airport performance, so you take the right decision, if I can say, to remedy on a given problem.
I see another one. So another question, Isaac, is how does the virtual twin integrate with our existing infrastructure?
So the objective of the airport experience is not to replace existing systems. So really what we are doing is integrating to all airport existing system, but only by providing integrated and single source of truth. So the platform have all the necessary openness, so we can integrate, for example, to an asset management system by really synchronizing the asset with the virtual twin, but also we can synchronize the work order with the work order within the platform. We can also provide connectivity in real time to an IoT system. So we have, based on the experience and engagement we have with some airport, we believe that the platform is enough open to really connect with all the airport system, actual system, to be able to provide this single source of truth and virtual twin of airport activity, and with minimizing impact on existing system.
And I see the question, are the infrastructure of the airport are included into the operation management system, pavement, tunnels? If not, is there any API with existing asset management system for infrastructures?
So today, what the way that the for existing infrastructure, what we are doing today, and this is, I'm in the middle of a project on that. So if we have BIM data, of course, we can bring the BIM data, convert the BIM data, and then be able to create the virtual twin of an existing infrastructure, including the asset. And then we can, through APIs, map the asset management system to the virtual twin, so we can create a correlation between the assets. So if we get an alert from an asset system, we can really visualize the information in the virtual twin. Also, we need also to look on how the asset management can also provide the information to the IoT, because in the end, you have an IoT connected to the asset. So you have two ways that could be connected: an asset system, for example, in the virtual twin from a direct to an API, but also from the IoT when we can get alert and really visualize the information to the alert. I hope this is answering the question.
So I hope yes. So I still see one more question, Isaac. How does Dassault Systems see the digital transformation of airports evolving in the coming years?
So what we see very strangely, although COVID-19 create a very difficult financial situation for airport. We see a lot of demand of digital twin and virtual twin, and I think that people are airport are now understanding the value of digital twin and virtual twin. What we are trying to explain to airport is moving to, for example, digital twin, which would be a GIS approach, have a lot of limited, so it can bring some benefit in the short term, but if they want to look on the long term, I think virtual twin, when now you don't connect to a 2D map, but now you are really connected to a 3D, which represent the real life, can bring airport to a long-term vision to what they want. There are some airports that are more advanced in their approach, like Auckland Airport, in which they really understood that, and many airports are starting to understand the value of the virtual versus the digital. But digital twin is becoming a key initiative for many airports in the world.
Thank you, Isaac. So I can't see any further question at the moment. So let's wait for a while if new appearing. No more questions? Yes, so in case there are not more questions coming, I suggest that we can close the session. So thank you very much for your interest, and we hope to see you again. All the best and goodbye.
Thank you.